Hey everyone, doing something a little different from my usual riding videos today. As some of you might know, and I'll put a link in the description to my website. I fly drones kind of professionally. It's more of a side business, but figured I would show some of my fleet and this new build that I'm working on for next season. Just to start off, this is going to be an AOS RC HS5. I have some of the core electronics here. Still waiting on the frame as of recording right now, but I'll get into that later into the video and do a little bit of a build log for you guys. This is a very high speed. It's meant for larger tracks. It'll go around 200 miles an hour. If you look it up, it's by Chris Rosser, the design and everything. And for the most part, I'm using kind of the standard list of components that he recommends, just a couple exceptions here and, a couple notes that I'll include for anyone else that's looking to build something like this. But anyways, to kind of show my fleet a little bit, I have this Darkstar 20. This is a GEPRC bind and fly quad, little 2-inch props. I mostly use this for like indoor stuff and like real estate tours, kind of business tours, things like that. Doesn't get as much use as I'd like, unfortunately, so it kind of sits around a lot. Like to fly it around the house sometimes. It's pretty fun, just easy to fly and not too worried about crashing because it has prop guards. It's real light. Runs on little 2S toothpick batteries. Has an O3 air unit, so you get that nice 4K footage. Don't have to run an action cam or anything like that. As you've probably seen from some of my videos on my channel, I don't do much YouTube videos anymore with flying, but you can see a lot of the clips and stuff that I do on my website. I usually use this 6-inch quad. It's kind of hard to see there. This is my kind of go-to for kart tracks and smaller tracks. It's a 6-inch quad, like I mentioned. Has an axis flying. I believe this is a Manta 6 dead cat frame. As usual, I run O3 on it. Pretty much what I always fly. It definitely has a lot of flight hours on it. It does pretty well. It gets anywhere from 5 to 10 minutes of flight time, just depending on how fast the vehicle I'm chasing is. But yeah, the motors are a little undersized, little 2306. I think these are 1700 kV motors. 6-inch 3-blade props, 3-inch pitch, and pretty basic budget. SpeedyB stack, no GPS or anything, just a basic Express LRS receiver. I don't run an action cam or GPS or anything, just to keep it as lightweight as possible. I have a DJI Action 4. That's what I use as my helmet cam in a lot of my other videos. So I have the clip mount on here just for nighttime flying, which the O3 isn't particularly good at. But other than that, it's a pretty good little quad. Definitely learned a lot from building this first one, and you can see it's got some wear and tear, has a lot of flight time on it. But moving on to the new build, like I mentioned, this is going to be an AOS HS5 by Chris Rosser. This one's a little different from your typical 5 or 6-inch FPV drone. It still has a carbon frame and everything, but it has some printed aerodynamic parts to it. Kind of looks like a torpedo with 4 motors attached. I went with a pretty standard build list that Chris Rosser recommends. These are T-Motor Velox 2808 1950 kV motors. Pretty beefy motors for a 5-inch quad, or 5.3-inch in this case. But for the speeds it's doing, these are supposedly very good. So we'll see at the end of the video during the test flight. Chris Rosser recommends a few different flight controllers and ESCs. I went with the Blitz F7 stack by iFlight. The main reason I chose this is because it has JST plugs for pretty much everything. I can unplug the receiver or the GPS. Having the O3 be a plug is pretty standard nowadays, but that too. So I can unplug everything, take the flight controller out if I need to. And it makes assembling, which you'll see later in the video, it makes assembling a lot easier with how the HS5 is put together. A couple little quirks about this is when you buy this E55 ESC, which is a BL Heli 32 ESC, the capacitor is surface mounted to the PCB, and with the HS5 you're going to have to run the ESC upside down. Because the battery bay is at the bottom, you need to solder the XT60 pigtail kind of upside down like that. Normally it's surface mounted on the other side, and with all these wires here, it gets in the way. It's very easy to break them. It doesn't really sit straight. So I removed that. I have an XT60 coming that has a 1000 microfarad capacitor up here at the pigtail. So that gives me all the room I need a little bit higher capacitance than the one that it comes with, which should help with kind of those full throttle pulls where this is pulling quite a bit of power. For the GPS, like I mentioned, I don't normally run GPS, but I would like to see in my goggles the kind of speeds that I'm reaching on GPS. So I went with a basic M10 GPS. This one's from GEPRC, just a little 4-wire plug with the standard TX RX. Doesn't have a magnetometer or barometer or anything. If it did, I would need to solder SDA and SCL wires to that flight controller, which I'm trying to avoid soldering as much as possible. The only thing I have to solder on this board are the motors, of course, and the battery pigtail. So just kept it simple with that M10 GPS. Same thing as my 6-inch quad, just running a Radiomaster RP1 2.4 gig receiver. I have it nicely soldered and heat shrinked, pinned out to a JST plug. So once the frame arrives, which will be, with the magic of editing, pretty short, we'll cut to some soldering, getting the motors in, kind of assembling the quad. I've already done some of the firmware stuff on the flight controller. I've updated it to Betaflight 4.5, updated Express LRS on the receiver and on my radio, which is a Radiomaster Zorro. The O3 is activated. It needs to be bound still, but I'll have to run power to it, which is not possible yet. So we'll do that later in the video. Chris Rosser has a PID tune already on the Betaflight repository for this quad, so I've flashed that to it, configured pretty much everything, got the OSD set up how I want it. Once it's assembled and just a couple more software things like the prop rotation and stuff, we should be ready to fly. All right, so here we have the frame, just arrived. Got it, everything laid out. Pretty nice quality prints overall. One thing I do wish that these files were open source. Unfortunately, they're not, so if something breaks, you'll have to get it printed by Brain 3D, I believe. But overall, the parts are pretty nice. I'm still waiting on the XT60 connector before I can actually put the ESC on the frame and everything and get the build started. Once that comes in and I get it soldered, then we'll cut to kind of a build time lapse. And before we get to any soldering, I've went ahead and made my life a little bit easier just by bending the motor wires, which is something you have to do with this build. There's a little notch in the frame here, and I've just zip tied them in place so I could measure the wire length, cut them just a little bit, maybe a few millimeters of slack, strip the insulation off. So I've done that for all 4 motors, and then I'm going to tin the wires and then solder them to the pads on the ESC. And then another thing to note, and I just noticed this when I was looking at how the plate assembles, there is this nice TPU piece that comes with it for your 2.4 gig antenna and your O3 antenna. It's all packaged here on the top plate. But the frame kit does not come with the screws that you need to mount the O3. The ones that it comes with are just M1.6 by 6 millimeter long screws. Definitely not long enough. Just this plate and this TPU mount, which uses the O3 screws. This adds about 4 millimeters. So I've overnighted some M1.6 by 10 millimeter screws so we can mount everything correctly. So with that, we'll start the time lapse, get this thing together. Alright, so before we throw some propellers on, I'm going to go ahead and connect it to Betaflight, reorder the motors since we flipped the ESC upside down, and also test the propeller direction, make sure everything's correct. Then once we bind the O3 to my goggles, we can go ahead and do the test flight. So I'm going to connect this Betaflight first, just via USB. And I have a battery. This is not the battery that I'm going to be using. This is just what I use on my 6-inch quad. I have some Tattoo R-Line 1800 milliamp hour batteries coming. Surprisingly, they're about the same size. So we'll just use this to test the motors. All right, and just so because we're spinning the motors, I'll pop the battery in here. Close enough. In Betaflight, I'm gonna go to our motors tab, and we're gonna run through both of these wizards here. First is to reorder the motors, and this is the front of the quad facing that way. This is gonna be motor 2, this is 4, this is 1, and this is 3, just like it shows here in Betaflight. So we're gonna go ahead and do reorder motors. Yes, the props are removed. Start. Okay. All right. There we go. Then we hit save. Alrighty. And we're running out. So I've checked this. So now we're going to check our motor direction. And I'm just going to kind of brush my finger on the bell of the motor. Obviously I don't have propellers or anything. Make sure you don't do this with propellers mounted. So we're going to understand, and we're going to do the wizard, why not? Click on motor numbers. Number 1 is correct. Number 2 is backwards. Okay. Number 3 is also backwards. That's good. And number 4 is spinning the correct way. I'm going to stop motors. So now that the propellers are confirmed we're spinning in the correct direction, our motor numbers are correct, we'll just go ahead and bind them to the goggles and go from there. So here it is with the propellers on, and just a few more notes before we go on a test flight. The prop spinners that it came with, while the quality's good, I actually cracked the first one I tried to put on, just because of the pitch of these propellers. I think these were designed for the 6-inch pitch or 6.5-inch pitch, whichever one the APC or HQ prop ones. So what I've done is I've designed different prop spinners that have a larger side opening. They're also just a little bit beefier, I think. They weigh about the same, but I've designed these in Fusion 360 and printed them on my Voron printer. And I'll leave a link in the description to this part on Thingiverse. That way you can print it for yourself. Another couple things to note is the screws that come with these T-Motor Velox motors, even the long ones, they're too short with the plastic fairing to go through the frame and then actually have enough thread to thread into the motor. So I've used M3x12 screws, just normal socket cap screws. You can kind of see them there. And then another thing too is the screws that come with the O3 camera, they just come partially threaded in. They're also too short. They are thick enough to go through the plastic, but they don't actually thread into the camera. So I've used M2x6 screws as well. And the only other thing to note, I know I mentioned that I would have the capacitor on the XT60 pigtail, but there's actually not that much space in the battery bay. So I put it back where it was on the PCB. I just cut it off of the XT60 and soldered it here. Just gave it a little bit of extra so I could move it out of the way. So all the cables have ample room, and the O3 antenna is right here, so that's why it's kind of off to the side a little bit. But other than that, it's all completed, and we can go take it on a test flight.
Holy shit. I lost it. Woo. Holy.
Alright, we're back from the track. Unfortunately, I didn't show it in the video. I did land it a bit too hard at the end. It is very hard on the LiPo batteries, and you can only do 3 or 4 high-speed passes before it drains the voltage really low. It was really cold at the track, so that probably didn't help the battery as far as how long the flight was. But basically coming in for a landing, the voltage sagged pretty low to the point where the quad couldn't really stay in the air, and it just landed right on the edge of the asphalt and basically shattered the battery bay. One of the drawbacks of printing with PATG. Anyways, the frame is okay. The top shell, besides the scuff, is okay. Everything works. I managed to recover the footage, which you just saw. That was the last flight. Broke a few propellers, and one of the prop spinners broke at the layer line on the print. The rest of them held up pretty well, and that's kind of a testament to why you should print in ABS like I did with these. It's just a lot more durable for this application than PETG. So I'm probably going to order another battery bay and probably a whole set of printed parts from Brain 3D just as backup. Definitely know not to drain the pack too much after that flight, and then I'll probably even try to replicate this, maybe make some improvements to it, and then print it out of ABS. I also want to, with the top shell, kind of extend it a little bit, make some room for a servo inside for the O3 camera, because it is very difficult to land unless you do a line of sight in angle mode. So with that, that's about it. If you guys enjoyed the video, like and subscribe, and let me know if you'd like to see more of this kind of stuff, or if you like the riding videos. Leave a comment down below.